looking at notes 11.4, Simplify Rationals. So here are your steps. Expressions, both numerators and denominators, must be in standard form. Second, factor both the numerator and denominator completely, including factoring out that lead negative. Third, state restrictions on the variables. Remember, I've told you this before, I know multiple math teachers have told you this before, 2 over 0 is not okay. You cannot have 0 in the denominator, but it is okay to have 0 in the numerator. 0 over 2 is okay. All right, and we're going to be using that a lot today for our restrictions. Fourth, cancel matching factors. You can only cancel tops with bottoms, top to bottom, not top to top, not bottom to bottom. Fifth, clean up and simplify. So before we begin, I need to refresh your memory in that you cannot cancel a piece of a binomial or trinomial. So first what I want you to look at is the beginning here, 11/12. 11/12 is a fraction that can be rewritten as 10 plus 1, because that's 11, over 10 plus 2, because that's 12. Okay, these two things are equal. This is 11 on top, this is 11 on top, that's 12 on bottom, that's 12 on bottom. It is very, very tempting to want to cancel this piece of this binomial with this piece of this binomial because they are alike. It's very, very tempting to just cross through and say, oh, that 10 over 10 just cancels. But that would leave me with 1 over 2, 1/2, that's all that's left. Is 11/12 equal to 1/2? No way. Okay, so you cannot cancel a piece of a binomial with another piece of a binomial. It's all or nothing. Either they're exactly alike or they're not exactly alike, in which case you cannot cancel. So factor first, then only cancel matching factors, only if they're exactly alike, and we're going to talk about that more here. Okay, so example number 1, 6x over 3x squared minus 9x. So I want you to simplify this. So looking at our steps, first, expressions, both numerators and denominators, must be in standard form. On number 1, we have both in standard form, numerator and denominator. Second, factor both numerator and denominator completely. Well, the numerator is a monomial, so no factoring needs to be done there. My denominator, however, has a GCF. As you can see, the GCF is 3x. When I factor out 3x from both terms, I get x minus 3. Okay, linear factor, meaning I'm done factoring. Okay, I've factored completely, so step 3, state the restrictions on the variables. So the restrictions come from what makes the denominator 0. We cannot have 0 in the denominator. So what values of x would make this equal 0? What values of x would make this factor equal 0? Because we can't have 0 here. So if I set 3x equal to 0 and solve, I would get x equals 0. So we have to say that x cannot equal 0. And if I set x minus 3 equal to 0 and solve, then I would add 3 to both sides and I would get x cannot equal 3. Those two values, when plugged in for x, would create 0 down in the denominator, not allowed. So we say cannot equal, x cannot equal 0, x cannot equal 3. Okay, once I've stated my restrictions, then I can cancel matching factors. So I don't have an x minus 3 on top, then I can cancel with the one on bottom. That doesn't cancel, but what I do have is an x that can cancel with this x. So those cancel out. All right, and then it says clean up and simplify. Well, I can also simplify 6 over 3. 6 over 3 simplifies to 2 over 1, or in other words, just 2. So I have 2 on top because the x is canceled. I have 1 on bottom, but I don't really need to put it. And then x minus 3 also stays on bottom. So my answer is this, including my restrictions of x cannot be 0 and x cannot be 3. All right, so looking at number 2. Okay, numerator and denominator both in standard form, we're good there. So then factor both numerator and denominator completely. Okay, that numerator factors to x minus 3, x plus 1. all right? And the denominator factors to x plus 1, x plus 4. Okay, so once I've factored, then I need to state my restrictions. So anything in the denominator that would make these equal 0. So that would be -1 and -4, because if I set that not equal to 0 and solve, I'd get -1. If I set that not equal to 0 and solve, then that would give me -4. So there's my restrictions. Once I have my restrictions, my fourth step says I can cancel matching factors. Well, x plus 1 matches x plus 1. I don't have anything else that matches. So my final answer is x minus 3 over x plus 4. Notice now that I don't have 2 on top and 2 on bottom, I got rid of the parentheses. And here I really could have gotten rid of the parentheses if I wanted to too. It doesn't really matter if you keep them when there's only one set. All right. Okay, look at number 3. Top, bottom, both in standard form. Good there. Then I can go ahead and factor. So GCF of 3 on top. That leaves me with x squared minus 9. Okay, nothing I can do on bottom because that's a linear factor. I notice I have a difference of squares. So x plus 3, x minus 3. Okay, once I'm done factoring, remember, do not forget this step. Once you're done factoring completely, state those restrictions. So here, x cannot equal -3 because of the denominator. Remember, I don't care about the numerator, only the denominator. And then once I've stated the restrictions, then I can go ahead and start canceling. So the x plus 3 cancels with the x plus 3. Nothing else goes away. So on top I have 3x minus 3. And you want to leave it factored out like it is. You don't want to distribute back in. Just leave it nice and factored. All right, moving right along. So number 4, our numerator has a problem. It's not in standard form. So -x plus 5. Okay, I've gotten it in standard form. Denominator's in standard form. Now I factor. There is a lead negative, so I need to take that out. That would leave me with x minus 5. And then nothing can be done with the bottom. It's a linear factor with no GCF and no lead negative. So x minus 5, I guess I'll go ahead and put it in parentheses just to make it really match. So you notice, oops, I'm canceling. Oh, I'm getting ahead of myself. I'm starting to cancel and I didn't do my restrictions. Uh-oh. So on bottom, before I cancel, I need to say that x cannot equal 5, because if you set that not equal to 0 and solve, you would get +5. I'm getting a little carried away with myself. I'm excited. Okay, so here, cancel out matching factors, and my answer is just -1. So -1 is my answer, where x cannot equal 5. Okay, so moving along, example number 5. All right, first of all, get that numerator in standard form. So -x squared plus 2x over, I'm going to go ahead and factor the bottom because notice it is in standard form. It's a simple trinomial. That factors to, let's think about it, x minus 2, x plus 1. Okay, and then on top I have a lead negative and a GCF of x, which would leave me with x minus 2, which is good because you're probably already noticing that matches something on the bottom. Okay, and before I get carried away like I did last time, I need to set my restrictions. So x cannot be 2 and x cannot be -1. All right, so now I can go ahead and cancel my x minus 2's. Good to go there. And then that leaves me with -x on top and x plus 1 on bottom. All right, 6th example. Top, bottom, both in standard form. Okay, 3x plus 4. No GCF, no lead negative, and it's linear. Can't do anything with it. That is a big help because when I look at this factor, now if at home you need to group this because the a is not 1 and you You can't just do the t-chart like we've been doing here and take the numbers from the t-chart. Can't do that. Okay, you either need to group or do guess and check, you know, the mental method that I've shown you before. If you cannot do the mental method, then again, you need to go off to the side and do your grouping. All right, but this is a big help with the mental method because likely 3x plus 4 is going to be a factor because it's probably going to cancel. So, and it is 3x plus 4, x minus 1 is how this guy factors. Okay, before I get carried away, I need to come off to the side and do my restrictions. So think about this also mentally. If I set this not equal to 0 and solve, you move over the 4, it becomes negative, and then you divide by 3. So x cannot equal negative 4/3, as well as x cannot equal positive 1. Okay, so I've got my restrictions. Now I can go ahead and cancel. On top, I've got this 3x plus 4 that cancels with 3x plus 4 on bottom. Do not give that x minus 1 a raise. It doesn't deserve it. It does not get a raise. It stays on the bottom. Okay, put a placeholder of 1 on top since there's nothing else left. All right, last example, number 7. Okay, I notice both numerator and denominator in standard form. Then I need to factor out my GCFs. I have a GCF on top of 3x, and that leaves me with x squared plus 4x minus 12. Okay, on bottom I have a GCF of 6x, leaves me with x squared plus x minus 6. Okay, and then I need to factor further before I can give my restrictions. Okay, multiplies to negative 12, adds to 4. That would be x plus 6, x minus 2. All right, and then this one, 6x, multiplies to negative 6, adds to 1. That would be x plus 3, x minus 2. Okay, I want to cancel, but at the same time I need to give my restrictions. So x cannot equal 0, negative 3, and positive 2. Those are my restrictions. And then x minus 2 cancels out. My x's cancel out. This simplifies to 2 on bottom, right? Okay, so then I would have x plus 6 on top, 2, x plus 3 on bottom. That's it for today.